Welcome, everybody. Thank you for being here this morning. I want to start with a quick question. How many of you believe that extreme fast charging is a critical factor when choosing an electric vehicle? I would say 60%. And that's the topic of today, because what Storedot is doing over the last 12 years since we started is to work on a solution that was considered impossible to do, and still some people believe it is impossible to do, is to charge an electric vehicle in minutes. So the experience of the driver will be exactly like fueling. So some people think it's a very long vision, but it's actually happening today. 15 car makers are already testing the solution. So this is very real, and it's already shipping. So EVs are at an inflection point where more than 50% of adoption is expected of new electric vehicles that are coming on the road will be expected by 2030. And there's a growing variety of models out there, but drivers expect the charging speed to be the category leader, meaning when they go into the showroom, they're asking, how fast is this charging? And this is like almost question number one, because it used to be range anxiety, like how far can I go? But it's no longer. Now it's became, how fast can I charge? And if you charge in minutes, that's a game changer. And that's what we see from leading car makers as becoming a key category for selecting the vehicle. There are many roadblocks. By the way, it's not just the chemistry, but clearly we need to change the chemistry of the battery in order to enable this, because graphite-based batteries, the Nobel Prize in Chemistry for Goodenough et al. At 2019, where they showed that they can actually take the lithium and store it in graphite, they didn't consider the speed. They just wanted to show, which they did, which was amazing innovation, to show that you can take ions and store them in an active material, which was graphite, and the process was designed to be slow because it was new and because graphite is a very structured formation that allows you to place the ions almost like in a bookshelf, kind of book by book, ion by ion placement. This is not good for fast charging. So we need to work on a new chemistry. So the fast charging experience is becoming the necessary standard. So in order to solve this, and I'm talking 120 people for 10 to 12 years, 40 of them are PhDs. Okay, so if somebody is, from any university, we are talking 2 faculties of research. Everybody is working on this one problem, one thesis. How do you change the materials of the battery so it will eventually charge in minutes as opposed to hours? This was our mission. And this is what we've raised over 200 million in order to do that. And this is what eventually we delivered after a decade of hard research. So what we are delivering is a chemistry that is charging in 10 minutes. This is at least 2 times faster than anything else that is out there. And the consecutive extreme fast charging cycles is really the game changer. Every time you want to charge, every time you need to refuel, recharge, you can do this in minutes. And this will not degrade the battery. The battery will degrade, because any battery degrades, lithium deficiencies or what have you, but it will not degrade because you charged fast. And this was a key assumption when all the car companies and battery makers, when they approached the problem, the inherent assumption was that if you will charge fast, the battery will die. And we are totally changing this with a silicon-based battery that is doing 400 watt-hour per kilogram. Not in this generation is 350, but it's like state-of-the-art energy density. Tesla is at 270, okay? So better than Tesla, but charging in minutes. Also, what is critical is that we are using a technology that can go plug and play into the existing factories. We change nothing on the production lines. And we already produced tens of thousands of these cells, no change to the production line. This is critical because tens of billions, if not 100 billions, are going into gigafactories today. We've heard it over the last 2 days. So many factories are being planned. They are being planned with the traditional equipment. We use this traditional equipment. This is how our pilot line is built, and this is how we are producing at a number of locations worldwide. And there's a roadmap of how to take this technology further. Today, we deliver what we call 100 in 5. That's 100 miles charged for each 5 minutes of charging. So you come, even if you come at 40%, 50%, 60% state of charge, where if you come, let's say, with a Porsche or with a Tesla, you cannot charge fast because the battery is already at a high state of charge. They will charge slow, not to damage the battery. So it doesn't matter what state of charge you come, we'll always give you 100 in 5. And we already have the samples for 100 in 4. So 100 miles charge every 4 minutes of charging. This is still with silicon. And we are moving to a semi-solid in 2028. A semi-solid will enable 100 in 3. And then there's a long vision that I believe will be very difficult to achieve, but still we have a team working on that. 100 in 2, that's the holy grail. That's an experience that is better than fueling. 100 in 2, right? So we are already in active testing in 15 locations of 15 car makers worldwide. Anywhere in the world. So when you say 15, you can imagine it's everybody. Think about a name, they are testing our battery in the vehicle. So this means that they are taking it very seriously. It took us, like 18 months ago, nobody wanted to test. Why? Because they said you don't have the cycles. Now that we have the 1,000 cycles, everybody is testing the battery. So what's the innovation here for bringing this 50% reduction in charging time with the same energy density and even better to get there 100 in 5? What we are working on is a solution that will not damage the battery, because if you look at the highlights from the manuals and also on the dashboard from existing car makers, and this is a Tesla, a VW, a Porsche, they all give you the warning, don't charge fast too many times because the battery is not designed for it. Yes, you can charge fast when the battery is empty, but don't do this very often. So we show zero degradation of the battery because of this fast charging. Just to illustrate, if you look at the profiles, and this is public information, the profiles of how a Porsche or a Lucid or a Tesla or a BMW, how they charge, and the y-axis is the power of the charging station. Let's say we have a 350 kilowatt station, and the x-axis is the state of charge of the battery. All of them, they can start high, but very quickly, depending on the profile and the cooling management and the BMS, they have to very quickly taper it down. When you get to 20, 30, 40% state of charge, you get only half of what the charging station can do. So it's really a wasted infrastructure. You cannot use the high-power stations. This is all like, it's games of the mind. You come to a very powerful charging station, but you don't take advantage of it because the chemistry is not designed for high-power charging throughout the cycle. What you see on the top in purple, this is a silicon Storedot technology. You can maintain 350 kilowatt until you are at 80-85%. If you, some of you understand, this is constant current. We are keeping the current, we can keep it constant current phase until the battery is almost full. This is very different than graphite. In graphite, very quickly, when you are constant current, you hit the upper cut of voltage, and you have to take down the current. This does not happen with silicon, because the whole structure of the silicon is different. So if we look at the evolution of what's happening with batteries, with graphite, this is the black circle, you can achieve that much. As you move to the silicon, and this is in purple, the silicon enables you a better performance, better energy density, and high power. And of course, in the future, with semi-solid and solid, as we move to the 103, there's more capabilities. But today, what Storedot delivers with silicon is almost at the end of the envelope of what silicon batteries can actually deliver. Now, why silicon? It's pretty obvious for those who come from the chemistry world. Silicon has 10 times the potential energy of graphite, and it can fast charge. So as opposed to this bookshelf that I explained earlier, think about a balloon, right? So all the ions can flow in very quickly. You can push everything in seconds. The problem is the swelling, right? And this is a challenge. So there are 4 different strategies to deal with the challenge of the swelling as you charge, and then when you discharge, it basically compresses. So this breathing mechanism is actually what creates the cracks and killing the structure of the anode. So in order to mitigate that, we have 4 teams. Each one is 10 PhDs that are in charge either on the electrolyte design, the binder design, the materials, the composite materials that go into the structure, and the nanotechnology, the size and the shape of the nanoparticles of the silicon and the carbon, the hard carbon that are all mixed together. So these are the 4 strategies that, that we worked over a decade in order to mitigate the challenges of silicon. And we also see that many car makers are asking either for a pouch or a prismatic or a cylindrical cell. It is very hard work to take a chemistry from one form factor to the other. So we are doing all this work in parallel. What we shipped was originally pouch, but now we are also shipping prismatic, and we have samples of the cylindrical cells as well. So if we look at what are the takeaways from what we've done over the last decade, we have reached a solution that can charge in 10 minutes, and the typical use case is 10% to 80% of the state of charge. So usually people don't get with 0, and they don't charge over 80 in these 10 minutes. So 10 to 80 in 10 minutes. This is 2 times faster than any premium solution out there. With, as I mentioned, 1,000, actually we are at more like 1,300 today, of consecutive fast charging cycles. We do not degrade because of that. And this is critical. This is, you need to understand, this is a flying carpet. This was considered impossible to do. I had many professors and experts and due diligence from major VCs. They all told me, you're wasting the 200 million, this can never happen. But we insisted because I saw it in the lab, I knew it can happen. And a few years ago, we started seeing the cycles coming up from 50 to 100 to 200. Every month, we like doubled it because of this strategy of working on all the strategies together. So we are providing today more than 330 watt-hour per kilogram. Again, Tesla, 270. Okay, so that's 20% better in the range, and it's fast charging. So we can actually deliver a solution very quickly to those car makers who are asking for some customized form factor. And we already have Volvo and Polestar and VinFast and Daimler and BP and Eve as our producer in China, also as an investor, TDK, Samsung, Ola Electric. So basically from each continent, we have like a major investor that is interested in taking this into the world. Thank you very much.
Thank you. Thank you so much, Doron, for this fantastic presentation on a real breakthrough innovation. I would like, because we still have a few minutes that we could use for questions, very few minutes, I'd like to take the one from Angelo that refers to the market, actually. Does extreme fast charging really play a role in urban mobility, or is it only for long-distance travels?
The experience of the driver should be exactly like fueling. People don't have time to stay and charge. Most people don't have homes, don't have garages, they don't have a place to charge at work. They want, when they want, and especially, by the way, the housewives. Okay, you know, no offense, but you know, if you talk to my wife, she doesn't want to think about it. She doesn't want to know that she charged overnight, she did charge, she didn't charge. She wants an experience that is exactly like fueling. So it doesn't matter if it's long travel or short travel. In order for mass adoption of electric vehicles to work, the experience should be like fueling. You go in and out in minutes, and you are charged. You're ready to go. If we can't solve this, people don't want this headache of the charging.
All right, thank you, Doron, for the quick answer. We can take a few more. The questions are just flooding in. Fantastic audience here today. One of them is, the question concerning charging times. What are the key factors influencing the charging time of an electric vehicle battery from 80 to 100? And how can Storedot be dealing with this? How much time do you need for charging from 80 to 100%?
So from 80 to 100%, it's really a question of, what is your use case? If you're really, now it comes to the previous question. If you're on a long trip and you need 300 miles and you're willing to damage the battery just a tiny bit, we can also do this in, let's say, 5 more minutes. 5 more minutes you'll get from the 20 to 80, from the 80 to 100. We actually recommend 10 more minutes, but just to be on the safe side. But again, usually, I would say 95% of the cases, people charge 10 to 80. And 10 to 80, there's no damage to the battery whatsoever.
All right, time for another one. And this is one that I would like to take about the cost situation. So the question by Anonymous is, silicon is very expensive. How do you plan to make your cells affordable? And maybe you could also refer one more time, because we're getting a lot of questions about the volume expansion. Maybe you could tie that in with the cost situation.
So silicon is the second most abundant element on Earth. After oxygen, you get silicon, basically sand. Okay, think about sand. Sand is silicon. There's no problem of silicon availability. There's no problem of silicon cost. There is a problem of processing, because we need it at certain purity, we need it at certain size of particles, shape of particles, all kinds of parameters that we optimize. That's where the cost comes from, and this is a scale issue. We are now producing, let's say, 0.5 ton, but we need many, many tons, right? So so cost will come down. It's still expensive. It's still more expensive than graphite, but also don't forget, I only need 1/5 of the silicon for the same amount of graphite, because like we said, the energy is like 10 times. We don't use the 10 times because of the cathode, but never mind. It's a way for us to really reduce the size of the battery and improve the energy density, and the cost is reflected in the cost per kilowatt hour as well. Now, the expansion of the silicon is the strategy of how we build the hosting matrix that holds the silicon in place. And this is the work that we did with the scaffold of the carbon that is preventing from the silicon to expand beyond the 3D structure, let's say. So there is an expansion, there's nothing you can do, but think about a nanoparticle, which is like a little golf ball that expands within a certain confinement. There's not much room for it to expand. If you compare it, let's say, instead of one golf ball, you have many golf balls and one basketball. And this is the original particle size. If it's a basketball and you inflate it, then it gets too big and detaches from the surface of the anode, and this is like you lose the energy, and this is also a safety concern. So the reason to go to smaller and smaller particle size is to manage the swelling and to enable the fast charging, because also the surface area is much higher with smaller particles.
Excellent. And because this one question is so hot, I'm going to go 1 minute over time. It's got so many likes. It's about the competitive situation. CATL has recently announced their 4C superfast charging LFP. How does your technology compare, Doron? Quick answer.
So CATL is the best company, and LFP is also a great technology, but don't forget, this is 30% less energy than NMC. We're using NMC. So it's a great cost-effective solution, LFP. It's also designed for a supply chain that is mostly in the East. It will take a long time to develop LFP in the US or in Europe. And what they don't tell you is how many times you can actually charge that fast. It does degrade. And they will get the same announcement, please don't do this every time, because you're killing the battery. This is the first and only solution, that can deliver extreme fast charging consecutively without degrading the battery.
Excellent. Thank you for the quick answer, and thank you for the inspiring presentation.
Thank you.